Okay. So, hello everybody. We are back, and after some time, I have to admit, it took me a bit of time to record the second part of the video, and I was also a bit like worried on how I was going to tackle the scope of it. What should we bring here new? And but now I think I also got some new feedbacks from people that watched and people close to me. And so now I'm gonna try to make shorter videos so people can have more of an easy time while watching them. And yeah, we're gonna keep open here for feedbacks. So what we're going to do, just a small recap, and now let's go back to the code from the last video. So, okay, this is our code. I did add some changes. This is the legacy I kept here from the last time. And yeah, so okay, so here I changed the bit of the layout, and then we're gonna follow two different paths. So what we did on the last time, so this is gonna be our main executor, right? Let me just make the screen a bit bigger. Okay, this is gonna be our main executor, and yeah, so this is our first main function, the one that actually mines the focal places. And if you're still in doubt what we're actually doing here, please revisit the back video, even though from here you can get a bit of the context, but still. So yeah, going forth. So alright, so we iterate a polygon inside a rectangle polygon iterator, and here I wanted to add new stuff because since the place, since the cities last time worked really nicely, I expanded them a bit, and now we have lots of cities. Now we have Antwerp, we have Ghent, we have Brussels, we have Bruges, Leuven, Mechelen, Charleroi, Liège, Namur, and Mons. So here I'm attacking the different. I guess I went to Wikipedia and took like the top 10 cities, and I tried to make a rectangle with similar area to tackle. Even though, so what I wanted to actually do is grab the main metropolitan area. So depending on the city as well, Brussels is a lot bigger than Liège, than Namur, for example. So yeah, that's changed a bit the proportion. But yeah, we want to extract most data out of it. So okay, we're gonna be extracted from here. This is some data from where I'm gonna send it, and let's go back to our main. Here the utils, I can close it. All right. So this is actually the one that mines, and this function produces the JSON. So let me just go here so the steps are clear. Produces the JSON files. All right. And afterwards, I made two paths. The first path is this run tables function. What does it do? What does it do? This one goes here, loads all of the JSON inside the temporary path, and it's gonna send it to where is it? So we append unpack tempos. Okay. Yeah, we go back here, and then we extract a huge data frame out of it, and then we send it to GBKey. What is GBKey? Our friend Google Cloud. And so here in Google Cloud, we will be able to see them. Let's now open Bigquery and Studio. Right? It's just loading a bit. Okay. So here, and oh yeah, right. And here, I just wanted to pass by. I don't think this was the scope. I built everything here using Terraform. But I think I'm gonna leave that for another video. I think right now that will make it too long. So okay, this is the structure of our table. So this is what I created in Terraform. Let me open Terraform here, just so we don't die out of curiosity. So just simply Terraform. Let's just no cancel, because I think it wants to open a new to overwrite our existing window. So if we open a folder here, we go to my repos, we have Terraform. And now, so we're just gonna take a look real quick And so basically it's very simple. I didn't make it everything so ultra fancy because we don't need it. We just have a single table, a single schema. So the Terraform is really plain. And what do we need here? We need a main, and this main is gonna say what provider we're using, right? So we're using Google, and we're specifying our project and region. And here, my dataset, simple. We have a single dataset, which is the FSKey project, which is the one we saw here, and just change its names. So it's actually shown as FSKey places. And all right. And we create our tables here, and our tables consume, so FSKey places. There's a simple description, worker places, data mine from the API, and its schema. That's the nice thing about Terraform. Its schema can be saved elsewhere. So I put inside resources and FSKey place schemas.json, and this is exactly here. So this is the structure of the content of our table. So here, there's the important thing. This is structured data. This is already pre-structured. Okay, yeah, it's structured in a kind of a bronze model. So it's the raw, the structuring based on the raw input, but it's still structured because here we say our strings, it's nullable, yeah, but we are reinforcing types on certain types of data. But yeah, so almost everything here is a string, and just the ones that I could really enforce as float and int are done. The rest, the idea is to treat on Google Cloud. But here is good. So yeah, that's why we see everything here. So this is the structure of the data we pull. And okay, so we run the table, send to GCP. So this sends data to Google Cloud. Good. And then also what we do, it's now. So we do a second path is we're gonna send it to Databricks. Yeah, and this we're gonna follow a bit more of an unstructured way of going. All right. So what we're gonna do is we're gonna take the data that we extract and we're gonna send it to Google Cloud bucket. You see? So we have a destination bucket which gets it, and this destination bucket is used here in this upload blob function. And blob, it's a binary object, and that's we're gonna send it to our bucket. And this blob is simply we use Google Cloud Storage Client, which is an API wrapper. And all right. And okay, so this guy sends raw data to GCP bucket, which will be pulled by Databricks. All right. So okay, and then I define the functions. Then I execute them on the order one. So first we mine, then we run the tables, then we do deploy roles. These both are the same information, but they go to different places. All right. So let's run this, and it will take probably a bit of time. So I'm gonna have to jump in the future. Let's say run present file. Where's my terminal? No, we don't have a terminal. Well, then perhaps we don't need. You see here all our polygons going, and fast forward the time.
A few moments later.
Okay, so we're back, and as you guys can see now, we have a lot of thing here, a lot of data. So let's just take a look at them. Yeah, Mechelen is a small city, and it's gonna have less samples, but let's compare to Ghent, for example. Well, yeah, it's pretty much different. And I left two to run here. Well, you guys can also check the output. So let's do both. Okay, and now, so if you check here, it was running quite a lot. And so some caveat. So I put a warning here because I made, if you guys remember, I blocked the polygon to 64 subgrids. And so in looking at here, I don't know which city is this, let me just check. Yeah, but we're in polygon 30, but doesn't matter. It means that if we reach the limit of the API, which was 50, So if we reach the API, there are two hypotheses. Or we got the exact number of venues inside that place. There was 50, or there was a bigger number than that, which means we are losing data. For the sake of this, we could do something dynamic and try if there is 50 and enlarge a bit. However, this is overkill, and I think like having 50 times 64 samples per city is alright, and also the maximum. And we don't reach the maximum every time. For example, like for this polygon here, we had 46, then 23. So it depends. Some areas are more clustered than the others. And alright, so now let's clear this again. Let's ask it to run in a new terminal. Dedicated terminal, and it's gonna run here, but okay. So bang, 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 bang. It's sending lots of people there, and a bit out of order. And but this one I want to wait a bit. If it takes too long, we'll just cut and jump to the future. Beep, 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 beep. Yeah, let's jump to the future. Wow.
A few moments later.
And we're back from the past. And well, so let's see. What did we run? We ran everyone. So let's just remind what happened here. So everything we downloaded and sent to our temporary folder now has been sent to places, has been sent to Google Bigquery, and has also been sent to Google Bucket. Nothing yet is on Databricks. Let's be reminded of that. So we check here our table. Let's run some base queries here. Yeah, I was doing a cleaning back before. It was a bit dumb from me to put the name of the schema the same of the table. Well, mea culpa here. And let's just count, right? I think that's good enough. Select count from FSK. And yeah, you guys see, we have 13,000 entries, which is good, right? And yeah, because the maximum, I don't remember, the maximum possible was, let me just, we had 1, 2, 3, let's do a clever way, 10 folders, we had 10 cities, so we had 10 cities, each 10 cities, 64 squares, it's 64, maximum 50. So this would be the maximum amount we could have, 32,000, which is alright. So we have our filling ratio would be around 13,000, 1, 2, 3, divided by the maximum. Let's just put on some parentheses here, and then this is the ratio.
Select 13000/10 asterisk 64 asterisk 50.
Yeah, 40%, which is good. I don't know if you guys heard, but this is my it's my translator to study Dutch. It sometimes gets tense. But alright, so 40%, well, I think this is a good number. And here we also send to our bucket. So our bucket separated from each one of these different cities. Let's check Ghent. So in there, we're gonna have like lots of JSONs here. JSONs are quite light, so that's good. And now, okay, so in Databricks, so there are different ways to import this data. And the way we're gonna import it here is basically, so we have a connector called Fivetran. I don't think this is the best because this is kind of expensive, and yeah, they try to, well, yeah, they try to execute this right now. But now let's do a sync. And what this wants to do is it goes here to my bucket. Let's check the bucket. This is it. Goes with my bucket, and this bucket has a permission for Fivetran to read the object. You see, it's good, it's kind of hidden, but there, object viewer. So this agent can go there and check it. Here, I don't know if it's breaking. Oh no, oh no. Let's check one more time. But yeah, the good thing is like we had a pretty solid success here on Google. Let's just take a look on how is our data looking like. So we see that some we have lots of different in data quality. So some of these entries are really good, they're really rich, and the other ones are a bit poor. So let's check like this, for example. We don't have the popular hours. This is spells V. So yeah, we have a reality metric from 5 square, because sometimes some stuff can be created by users and they are not checked, so they have a metric of their own. So we have also the address, the country with they're operating, the locality, and so this is in Liège. And I think we can also do something nice here. It's select star. Let's take the first query here, and we're gonna select
Count.
star. Yeah, friend, I know. And okay. And so from fsq places dot fsq places, let's oh, if I group by, I'm gonna have to, so we count star. We also gonna take, I want the district, where was it again? So we want locality, locality, and from fsq places group by locality. So this will give us a rough amount on how, yeah, let's also order by, let's just give a name to this column so we can use it to order, as counter, order by counter descendant. This is good. Nice. So we have lots of empty, we have a lot from Antwerp, which surprises me. I would expect more from Ghent or Brussels. And yeah, but also, yeah, to remind, because this depends on the classification. So the big cities, they break into different clusters. So we might have lots of things here that look like a locality in itself, but they are actually a part of Brussels. So yeah. So let's check 5trend here. 5trend is having a problem, a connection error. The following buckets do not contain any files. Are you sure, my friend? Yeah. So guys, here I'm gonna limit. We're not gonna actually import here to Databricks. It's sad, but yeah, I also want this to be an extra path, but I think this pathway to GCP is already good. And yeah, I'm gonna debug this, but I really didn't like to have been forced using this. You see, it's a trial, and yeah, I think a better path is to actually connect our bucket inside Databricks, but this needed a bit more of effort on my side, and I focus a bit more, so we could just send data to Google Cloud. So, and this is it. On the next video, what I want to do is we actually take this and actually extract a bit of intelligence from it. All right. Well, I thank you guys for being here till the end with me, and yeah, wait for some next videos and see you. Bye bye. Wait up. I told you that 5trend was having a problem. Yes, it sucks having to use third-party websites for this. However, it was a silly regex that was trying to catch a specific type of phrasing that I put on my files, but no. But what I wanted to show is this is the path. This is ELT. This is ELT, and so here is the main difference we have between our ETL. So we extracted, right, transformed inside a layout that we had, because let's see, where's the T part from here? When we're gonna send here, we will say run tables. So I do mine, okay, data's already mined, and this load temporary data, this already has a layout to be in pandas, all right? So this is the transformation part. It is a simple transformation, yeah, because I wanted to keep the data as raw as possible. However, there is a difference here. To Databricks, we uploaded completely raw. So the data here has like the metadata is simple. Is file name, so here if you purchase a polygon number 34, alright, number of lines, yeah, it doesn't have any because everything is compact inside there. Modified data when 5 transync is the agent there, and here is actually our results. And this is the idea of the LT. We store this, and eventually we want to run machine learning algorithms, we want to run whatever is else we can consume from this, because this is the raw data, and then we manipulate it as we need. So this is the pure example. This is what I wanted to show. This is ELT, and send it to Bigquery was the ETL. Okay, now it's the official goodbye. Thanks for staying to me to the end of the video, and well, see you guys on the next one.